Welcome to Study Loop.
We're going to be considering the reaction of nitrogen gas and hydrogen gas to produce ammonia. We're given the following information. And these are at the temperatures of 300, 400, and 500 Celsius. Okay, we were given three temperatures and the Kc equilibrium constant at those three temperatures. Then we're asked, based on our equilibrium constant, is this an exothermic or endothermic reaction? In order to do this, let's write the expression, which will be as follows. This is squared. We can see that as temp increases, our Kc, our equilibrium constant, decreases. So we can include that with an increase in temp, the concentration of nitrogen and hydrogen increases. So we know that the equilibrium shifts left. And if the equilibrium shifts left when the temperature increases, then we're looking at an exothermic reaction. So we know that it has to be exothermic. Question B. Using standard enthalpies in Appendix C, determine, find delta, or find our change in enthalpy. So I'm going to just quick jot down our equation. Again, these are all gases. So I'm going to leave the states off. And our change in enthalpy equals our reactant, so this will be 2 times our ammonia minus the N2 plus the 3 times H2, the delta H's. Both these are 0 because those are standard states. So all we're going to do is take 2 times ammonia. And ammonia's is negative 46 kilojoules per mole. So this will be negative 92 kilojoules will be our delta H. So the value is negative, which means the reaction's exothermic. And we said it was exothermic. Let me go back and verify I said it was exothermic. I did say it was exothermic. Does this agree with your prediction? Yes. Agrees with part A. And then what do we have to do? For C, 0.025 moles of ammonia added to a 1 liter container find the concentration of ammonia after we're at equilibrium. And we're at 500 degrees Celsius. In 500, we can see that our Kc, equilibrium constant at 500 degrees Celsius, 0.058. That was given. So we're going to make an ice table. And it will be ammonia, it's equilibrium with these two. My initial concentration is 0.025 molar, 0 and 0. This will increase by x, and this will decrease by 2x. 0.025 minus 2x. X and X. And plugging this into our equation, thank goodness I had a graphing calculator for this. Kc is equal to, we already wrote this down once. This is cubed, and this is squared. So I ended up with this should have been a 3. And then solving this, I'm going to write what I got here. Then bringing this out, I ended up with and then finally I ended up with and when I put these numbers into my graphing calculator, the best I could come up with was my x was really close to this, 0.01. So now, if you recall from the ice table, we said our final concentration will be 0.025 minus 2x. So I take 0.025 minus 2 times 0.01, and that gave me 0.005 molar was my final concentration of my ammonia. And I think that's it. Let me make sure that's the whole problem.